Good morning, friends. Welcome back to the session on knowledge organization. I think in the last two sessions, we were discussing about first 5.1 and then 5.2, and we were discussing about some of the concepts in 5.3. Let's continue the 5.3. Okay, so the first class itself, I was telling you what is knowledge organization and what are the various knowledge organization systems we have in the libraries. To refresh you, a knowledge organization system is nothing but a list of a carefully selected list of terms which are structured, which are controlled. So those terms, maybe list of subject headings, maybe a thesaurus, maybe a classification scheme, whatever it may be. In all these tools, what we do, we select the terms, we finalize the terms, we arrange the terms in a particular order. So now these terms are going to be used for two purposes. Either for the purpose of describing the resource what you have in the library or what is available online. And whenever you want to browse your collections, you want to search for something, you can make use of all these controlled, structured, selective list of terms. Fine. Examples are thesaurus, classification schemes, subject heading list, taxonomies, all those things. Fine. But here we are not talking about knowledge organization system once again, but we talk about SKOS, simple knowledge organization system. This is a new concept where people are trying to develop some specifications. People are developing some standards so that whatever traditional knowledge organization systems you have, classification schemes, thesaurus, subject headings, how all these knowledge organization systems can be effectively utilized in the framework of semantic web. So we are living in web 2.0, web 3.0. We are talking about semantic web, where web starts understanding, where web starts behaving intelligently, where web starts understanding your demands, your needs, and then accordingly it produces results. So in such a kind of semantic web environment, how we can make use of the traditional knowledge organization systems, especially when we talk about online resources, internet resources, and web resources. Fine. Because basically all these knowledge organization systems, thesaurus, classification systems, Library of Congress, subject headings, all these things were basically prepared to describe the traditional resources, the so-called printed resources available in the library. But nowadays we got a lot of web resources, digital resources, online resources, e-resources. So we need some rules, regulations, specifications, protocols, and standards so that we will be able to either create a new system or we will be able to convert these traditional systems into a semantic web where all these traditional systems can be used. Fine. That's what this SKOS is all about. Fine. So SKOS is giving a standard way how you can represent knowledge organization system, whether it is a classification scheme or subject heading, thesaurus, how these knowledge organization systems can be represented in a standard way using RDF. You know about RDF? RDF stands for Resource Description Framework. See, RDF is nothing but a standard that gives you rules and regulations and specifications promoted by, designed by WWW, World Wide Web Consortium. We say W3C. So they have developed this particular standard for the purpose of describing resources online. So whenever you want to describe any resource using any kind of language, the base is RDF. Okay. The RDF basically it has got they follow a technique called triples. That is, they have a formula like subject, predicate, and object. So this is how they work. See, long back we had entity relationship model where we have entities, then we have attributes for entities, and there are some relationship between entities and attributes. That is the model we had. But now, in terms of web resources, we are having a separate model called RDF model, which has got three components called subject, predicate, and object. Fine. Basically, the purpose of RDF is to help you to describe the resources online. Fine. So, if you are using RDF to represent the already existing knowledge organization systems, then it will be very, very easy for you to have exchange of information between computer applications in an interoperable way. So there is an interoperability. What is an interoperability? Though you are having a different system, I'm having a different system, you are having a different software, I'm having a different software, different computer components, different computer. No, absolutely no problem. We can exchange it because it is interoperable. It can operate on any number of systems, any kind of systems. Fine. And since we are using RDF to represent the knowledge organization systems, it becomes very easy for us to have the implementation of knowledge organization systems in distributed, decentralized metadata applications. Fine. So nowadays we talk about metadata. Metadata is nothing but data about data. And we talk about decentralized metadata. What is that decentralized metadata? For example, there are 10 research libraries which are doing research in defense, for example. Fine. So all these libraries are having a lot of e-resources. They all have metadata. See, what you can do is that you can harvest the metadata from all these 10 research organizations, and you can provide a single point access to all these 10 metadata items. So that kind of decentralized metadata will become very possible if you are using RDF to represent the knowledge organization systems. Fine. So SKOS can be used as a model so that you can either share or link knowledge organization systems in the World Wide Web. Fine. So though you have different names like classification, thesaurus, subject headings, see, all are same in the sense they're all talking about preferred terms. They're all talking about descriptors. They're all talking about the terms, the control terms that can be used to express the thought content of the subject. Fine. That's what they're all doing. So SKOS captures the similarity existing in all these classification or subject heading standards, and they are creating an environment so that the data and technology can be shared among diverse applications. So what will be the software, hardware you have, you can exchange the data, absolutely no problem. And SKOS does three things. One is it provides a very, very standard and low cost migration path. See, nowadays what we do, without changing our numbers, we are switching over from one network to another network, from BSNL to Geo to Airtel, something like the same way. If you want to move from existing knowledge organization systems to a semantic web, then SKOS will provide you a low cost migration path. So using SKOS, you can migrate from your traditional knowledge organization system to a knowledge organization system that is required in a semantic web. So it provides you to migrate from one KO to another KO. Fine. And secondly, SKOS provides a very, very simple, easy to understand language using which you can develop your own new knowledge organization systems, and you can share this new knowledge organization system with the people you like. So either you can port or you can create new one. Apart from that, if you want, SKOS can be used independently, or you can use it in combination with other knowledge representation languages which are available online. For example, we have OWL, Web Ontology language. So even SKOS can work with OWL to prepare or migrate knowledge organization systems. Okay, fine. You can see here SKOS graph. So this is a typical thesaurus. See what is given on the left side is a typical thesaurus. Animals. Under that we have got cats, then domestic cats, then wild cats. For the cats, we have used for domestic cats. That is, instead of using the word domestic cats, you are instructed to use the word cats. Okay. What is a related term? Wild cats. What is a broader term? Animals. What is a scope note? Used only for domestic cats. That is, cats is equal to domestic cats. Fine. Then the term domestic cats, use cats. That means if you are preparing an entry for domestic cats, don't use the word domestic cats. You have to use the word only cats. Okay, this is a typical thesaurus entry used in a thesaurus. You see how this thesaurus, a traditional knowledge organization system, is converted into a SKOS graph. It's very simple. You can see here. See, cats is a term we are having. It has got a broader term called animals. What is a preferred label in SKOS? It's known as animals in English. If you're using English as a language, we are using the preferred label called animals. Fine. Then cats, what is the related term? Wild cats. What is the preferred label? It is called wild cats. Cats, the preferred label is cats. That's what is the scope note? Used only for domestic cats. What is the alternative label, alternative term for cats? Domestic cats. Okay, fine. So this is how we represent thesaurus in a SKOS graph. Fine. The same thing can be converted into RDF XML format also. So you can see here how the same thesaurus entry is converted into a kind of RDF XML format. You can see here. So concept is a website. So this is a website you are describing. What is the preferred label? Animals. Okay. First concept is animals. The entire thesaurus structure is going to be converted into RDF XML format. Okay. So animals is the preferred term, first term. Then second one is cats. Okay. What is the preferred label? Cats. What is the alternative label? Domestic cats. What is the scope note? Used only for domestic cats. What is the broader term? Animals. What is the related term? Wild cats. So this particular portion is over. The next one is we are talking about wild cats. Okay, we are talking about the wild cats. So the entire thesaurus is converted into RDF in SKOS schema. Fine. Here, how they were converted even the mark format into SKOS. Okay, SKOS. See, 010 control number. See, RDF is about the particular data. Topical term, they say preferred label with the subfields. Geographical term, we have preferred label. C reference, we are having alternative label. C also reference, we are having broader term. So, see, any kind of knowledge organization system can be mapped to a simple knowledge organization system. Fine, good. You can ask the question, what is this web information classification engineering? See, in a typical library, you arrange all the documents in a particular linear sequence using a classification scheme so that the users would be able to come to your library and retrieve the documents. The same way, even the web content, the content available in the web also needs to be properly, systematically arranged so that retrieval will become very, very effective. So for the purpose of retrieving the online content very effective, we need to make use of lot of knowledge organization systems. Maybe we can make use of classification schemes, thesauri, ontologies, and FOLKSONOMYs. Fine. Okay. So let us discuss about these tools. Okay. There are non-traditional tools. Taxonomy. So taxonomy is nothing but a hierarchical classification. Okay. You take a particular subject, you prepare a taxonomy. You can prepare a taxonomy for an organization or for a commercial organization or for a website. You can create taxonomy where all the terms are collected related to that organization. They are arranged in the hierarchical order. What is hierarchical? Parent-child relationship, superior subordinate relationship. In that way, all the terms are arranged. Okay, but in a broader sense, you can say that taxonomy means any kind of method you follow for organizing concepts of knowledge. You can say that taxonomies. Fine. See, basically, we talk about hierarchical taxonomy where just like a normal thesaurus, we have all the terms and we write broader terms for all the terms, and we write narrower terms for all the terms. Only thing is, all the items are arranged in a single large hierarchical structure, just same like what you see in thesaurus. Good. For example, here I just give an example for one taxonomy. These are the top level headings adapted in a particular library, for example, or in an information retrieval system, or in a company, or in an office. From here, I take one concept called leisure and culture. These are top level taxonomy headings. I take one item called leisure and culture. Under leisure and culture, various terms are arranged in the alphabetical order, wherein hierarchy is followed. For example, you take culture and creativity. Under culture and creativity, many items are there. These are parent, these are children, architecture, crafts, heritage, literature. Then if you take sports and recreation, we have team sports, water sports, winter sports. Under team sports, we have cricket, football, rugby. So this way, all the important terms are arranged in the hierarchical order. If you take this particular item called football, it is having a broader term called team sports. If you take team sports, the broader term for team sports is sports and recreation. The narrower terms for team sports are cricket, football, rugby. So this is how taxonomies are arranged. Here, these are top level taxonomy, what you see in Amazon.com. Now it is might have changed. I just taken an old screenshot. For example, Amazon has got a lot of taxonomical structure. The top level has got books, movies, music and games, digital downloads, Kindle, computers and office, electronics, home and garden, then health and beauty, toys, kits, clothing, sports and tools. These are top level taxonomy. Okay, fine. What is the purpose of this taxonomy? Taxonomy serves almost the same purpose as that of a thesaurus. In online mode, you can use taxonomy to create subject index headings. You can create index by taking words from taxonomy, or you can use the words available in taxonomy for the purpose of retrieving the required information from your storehouse. And thirdly, you can even organize your content, or you can set your content in such a way that the online users will be moving from one content to another content. Navigation is possible with the help of these taxonomical things. See, is one example for organizational navigation. See, for example, when you search for a particular keyword, now some results are available. At the same time, the results are organized, for example, from the point of view of the subject botany, in terms of resource type, and in terms of extreme environments. So the same content is organized under 3 or 4 filters. And navigation, you can always move from one concept to another concept. See, navigation has just become very, very simple because of this taxonomical usage. Fine, good. Then when you want to develop a taxonomy, see, basically there are 4 steps involved. So first of all, planning and analysis. You need to find out what is the topic on which you want to create taxonomy, what is subject, or what is the name of the organization, collect the terms. Then design, development and testing. You collect all the terms, you find out preferred terms, broader terms, narrower terms, you test it, you implement it, and then you maintain it. It's the 4 phases of taxonomy development. Then people have developed a lot of taxonomy architectures. See, we talk about flat taxonomy architecture, facet taxonomy architecture, hierarchical taxonomy architecture, and network taxonomy architecture. So making use of all these structures, you can build your own taxonomy for your institution. Fine. Okay, then comes ontology. See, even ontology is a kind of taxonomy, but the only difference is that in ontology, we have more complex relationship expressed between the terms. See, maximum taxonomy in a thesaurus, we talk about broader term, narrower term, related term, scope nodes. That's all. These are the only kinds of relationship we are expressing. But in ontology, you can describe any domain of knowledge. Any subject can be defined in terms of terms and the relationship existing between them. But in ontology, we are bothering about different types of relationship that may exist between terms based on the subject for which you are preparing ontology. So the relationship between the terms, they are not just restricted only to broader term, narrow term, but they are confined to, they are fixed based on the subject for which you are preparing ontology. For example, you can have such kinds of relationship as owns belongs to. For example, this car belongs to Ramasamy. Ramasamy owns this car. This kind of relationship. Producers is produced by. So for example, Sterlite company is producing oxygen. Oxygen is produced by Sterlite company. So this is a kind of relationship. Has members is a member of. For example, Ramasamy is a member of American Library Association. American Library Association is having Ramasamy as a member. So this kind of. So you can have any kind of relationship based on that topic or a subject or organization for which you are preparing the ontology. Okay. I just want to give two examples for ontology development. One is Chinese classified thesaurus, which was converted into ontology using this W web ontology language. One example, how thesaurus was converted into ontology. And secondly, we have something called a personal ontology recommender project, wherein a group of scientists, what they did was, see, based on the borrowing history of the users, they developed a personal ontology for each and every library user. See, if you take library user called K. Ramasamy, so we just see in last 5 years what kind of borrowing history he has got, what kind of books he is getting borrowed, what kind of things he comes and search in the library. Based on that, they developed a personal ontology for each and every library user. Fine. Okay. Then comes FOLKSONOMY. See, FOLKSONOMY, we talk about a very simple mechanism. Okay. It is a combination of two words, folk and taxonomy. So this is also a taxonomy, but instead of you as a librarian or the indexer, knowledge manager, you assign and you prepare the key terms and you prepare a list of key terms. The key terms for describing the resources will be provided by the users. So those who are going to use your resources will provide keywords called tags. Okay. So a FOLKSONOMY is nothing but a user developed, because we are not going to develop any keywords. The users are going to provide you keywords. This is a user developed. And bottom-up categorical structure development, because you are not creating a taxonomy, you are not asking users to make use of it. Instead, it comes from the bottom. Users are throwing the keywords. You take all the keywords from users and you start building your own FOLKSONOMY. Fine. So it is a structure that emerges from users tagging information. So whenever you read something, you provide tags, you provide keywords. Based on these tags, see, whenever you want to define as a librarian, whenever you want to define a e-resource, you are not going to take any term from classification scheme or a thesaurus or subject headings. Instead, you are going to choose the terms given by the users. That is what is called as FOLKSONOMY. See, many people have given different names for FOLKSONOMY. Some people say it is called a social classification. Some people say it is ethno classification. Some people say it is distributed classification. And Noruzi says it is collaborative tagging. See, everybody tags, everybody gives keywords. All those keywords are combined together and you create taxonomy. So it's a kind of a collaborative tagging where it is a kind of a user-generated classification system of web content. So we have got web content. The web content is going to be classified based on the keywords given by the users. It's nothing but an ad hoc collection of user-generated keywords. It's not permanent. Why permanent? Why it's not permanent? So users will keep on providing new keywords based on the new inputs, whatever you post in your web pages. So obviously, you'll keep on getting a lot of new words. So your FOLKSONOMY becomes a dynamic one. That's why it's an ad hoc collection. Good. Okay. What are the examples of FOLKSONOMY? We have Flickr, an image portal, which employs FOLKSONOMY to a great extent. 4-3 things. So Delicious is a very popular social bookmarking sites where you can go and create your favorite bookmarks and you can tag them. The Amazon is providing a facility for folksonomical concepts. So basically, folksonomy has got two characteristics. One is any folksonomy, they permit the users to add tags, to add keywords to the online information. So you can just go to a particular website. If that provision is available, you can go and give your own keywords. First thing. And secondly, after collecting the keywords or tags given by the users, you will be creating a kind of navigational links. If somebody come and gives a click on the keyword given to the user, that will be taken them to the particular resource. So you will be creating navigational links so that the users will be able to either extend or narrow their research process. And apart from that, the keywords given by the users will be used as a base for organizing all the information you have in your website or in your institution. Fine, good. So what are the trends in classification these days? And in DDC, DDC is basically criticized for giving more importance to US related content and the Christian related things. So they are trying to reduce the bias, Christian bias and US bias in DDC. And DDC 21 appeared in two formats, in print format and Dewey for Windows. It is based on Microsoft Windows. And there is a home page in DDC where you can get all the latest developments taking place in DDC. As far as UDC is concerned, the International Medium Edition in English was published in 1993 in two parts. First part, systematic tables and schedules. Second part, index. And they have removed the use of digit 4, which was previously used for linguistics. Now it is merged with and shifted to number 8, literature. Now both literature and linguistics are available the same number called 8. As far as research is concerned, classification research is concerned, we have many organizations like FIDCR, International Study Conferences on Classification Research being conducted by FID, International Federation of Documentation. And apart from that, even International Society for Knowledge Organization, they are also conducting international conferences on classification research. And we have Library Research Circle in Delhi. We have Classification Research Group in London. And we have DRDC in Bangalore, which takes up a lot of classification related research activities. And in fact, in 1978, FID organized a committee called BSO. BSO was given the responsibility of developing a new classification scheme that may be more suitable for web environments. The committee, after working for 2.5 years, they prepared a draft scheme called BSO, Broad System of Ordering, wherein they have introduced 2,000 subjects, not 1 or 2,000 subjects were listed, but notations were not given. So this was published in 1978 as the name, as entitled as Broad System of Ordering, Schedule and Index in 1978. Good, fine. So as far as classification is concerned, see, we have colon classification, universal decimal classification, Dewey decimal classification. So these are all general classifications meant for any kind of library. But if you want to classify the documents related to a particular subject, then you may need some kind of depth classifications or special classifications. So we could come across a lot of special classifications. For example, we have a classification scheme for soil earth science, which was developed by B.C. Vickery. Classification of social sciences by Kyle. Organizing the arts by Peter. Classification for the literature of jazz music, no? Longridge. So these are the special classification schemes. Then there is something called a reclassification. Whenever you are moving from one classification to another classification, you are following DDC in your library, you feel it's not sufficient, you want to migrate to UDC, that process called as reclassification. Then comes, nowadays we talk about automated or web-based library classification schemes. When people are trying to develop some schemes here and there, including WebDewey, for the purpose of creating automated classification numbers online. Fine. So that's about, that's the end of unit 5.3. I think you are clear with the concepts related to classification. Maybe I'll come back to you in the next video presentation on 5.4 cataloging. So thank you so much. Let's meet again.